starting again. I'm outlining the use CPT executed in difficult conditions using CPTWD and future developments. CPTWD stands for Cone Penetration Test While Drilling. Can be considered as an integration between a standard CPTU, a wireline coring system, and sometimes we use MWD connected to the whole system. MWD is monitoring while drilling. The CPTWD allows to alternate CPTU strokes with sampling coring down the hole testing, for example, SPT or pain test and so on. And it's possible to install geotechnical instrumentation, being the diameter of the hole more than 130 millimeters. I'm not explaining very well how the CPTWD works because it would take a long time, but there is a wide documentation in internet. However, CPTWD is not a down-the-hole CPT system. Basically, it's a standard piezocone with memory. It's not possible to use with cable, which is embedded into a wireline core barrel. The piezocone protrudes down the drill bit for 50 centimeters, so the CPTU data normally are not affected by rotation and pushing. Of course, the cone does not rotate thanks to bearings which are mounted on the inside of the core barrel. Differently from down-the-hole systems, the CPTWD is pushed by wireline rods and penetrates the soil as fast as the drill string does. Wireline is the method for recovering core barrels and tools by use of a wire. After the test is done, or whatever is required to take a sample, or if gravel, bedrock, or non-penetrable soil is encountered, the cone, CPT core barrel, is retrieved by an overshot driven by a cable, hence the name wireline. So it should move somehow. Doesn't matter. It was just an animation for showing how the CPTWD works. Going down, and the retrieval of the CPTWD thanks to the overshot, which is a tool for fishing the CPTWD once the test is done. I'm showing what CPTWD is useful for. Question. We use it for very deep CPTU tests. I mean very deep from 80, 90, 100 to 200 meters. I mean we use the CPTWD in all cases where the static penetration test cannot be done with a penetrometer. And we use CPTWD in these peculiar cases I am going to show you. For example, number one, CPTWD in very stiff soil carried out at a very low rate of penetration. With very low, I mean 0.2, 0.3 centimeters per second. CPTU test was performed in a site using CPTWD where the stratigraphy is from 0 to 13 meter gravel and from 13 to 160 very stiff silt. In that site, after pre-hole 13.4 meters deep, we tried out to push with both the CPTU cone and the marketed dilatometer standard methods. without any results because the penetrometer could not push in such hard soil. No penetration at all, also after having anchored the drilling to the soil like a penetrometer. Then we tried with CPT-WD with an extremely low rate of penetration, and we were able to get continuous data from 17 to down to 30.5 meters, and we could have tested much deeper. These are the results of the test. I had to enlarge the full scale of the QC-FS. The blue line in QC shows 30 megapascal. So it's a very hard soil. Second example. CPT-WD carried out from floating barge simply anchored to sea bottom with in all the tests ranging from 8 to 14 meters water depth in Adriatic Sea in front of Venice for the Venice Mobile Dam project. This is the typical result we got. You see the water depth was 8.5 and the total depth of the test was around 52 meters from the sea bottom. You see many oscillations, many vibrations on the graphs. These vibrations are due to the wave movement while the rig was pushing down the cone. It has been necessary to filter the graphs for taking away as much as possible the oscillations for fluctuations transmitted to the cone by the vertical movement of the barge and the drill rig. This is a dissipation test carried out during this campaign. You see also in the dissipation test, the small oscillations in the shape of the dissipation curve are probably due to the waves. Third example, CPTU and SPT in the same hole from floating pontoon with alternate layers of penetrable soil and gravel. At that time it was available only a floating pontoon, anchored with balancing location where the water depth in average was 12 meters. For soil characterization, we should have switched the penetrometer for CPTU and the drill rig for coring and SPT 4 or 5 times each location. Since it was not available the jack-up barge, we decided to perform the tests with CPT-WD using the available floating pontoon and a small drill rig for ton weight. Were carried out 2 or 3 tests per day down to minus 35 meters with a single shift 10 hours work. This is a typical situation of that site. Water depth was 12 meters, CPTU down to CPTU. This is the first stroke of CPTU, then take away the CPT-WD and make coring in gravel and SPT. Second stroke of CPTU, then coring gravel and SPT. Third stroke of CPTU, and finally the bedrock. So, the aforementioned jobs were made with CPT-WD in good weather conditions, with low speed or using a very big barge well anchored. The results show that the data might be affected by the vertical movement of the barge, even if the CPT-WD system of pushing is much more flexible than the standard penetrometric pushing. For this reason, we designed a simple system for heave compensation, which could be easily used with the standard rigs and penetrometers. This is the system. It is supposed that this is animation, but doesn't work. Excuse me, could you make the filmato noise? The blue part is the barge. The red part is the compensation system and the drill rig or penetrometer. back to the presentation. So I'm going to show you new developments. Since CPTU is not a universal test giving all the possible results, therefore we thought to widen the range of tests that would be carried out in the same hole, with the same drill rig, without changing the drill string. Therefore we designed and in some cases made special geotechnical and environmental wireline tools to be used with the same philosophy of CPTWD, like a wireline pilatometer, thanks to Professor Marchetti, wireline vein tester, wireline permeameter, water sample and the permeameter, wireline thin wall samplers, Shelby and Osterberg type. This is the first model I used in very stiff silt down to minus 180 meters. It's a sort of wireline down the hole water well to be installed in a pre-hole. We tested it successfully in a site where I cannot show the results because it's a nuclear site, but we made some cross-correlation with samples, other kind of laboratory tests and so on, and these permeability tests carried out in that site gave excellent results. This is the second model I recently developed, wireline sampler and permeameter. This is made mostly for taking undisturbed samples of water. It's made up of a tube containing an under vacuum vial connected to a filter. The bottom of the tube has an auger which penetrates the uncontaminated soil at the bottom of the hole. Once the auger penetrated 1 meter, the drill string is pulled up and the filter is mechanically opened, so the vial starts to be filled. A pressostat on the top of the vial measures the variation of the pressure versus time, so to get the permeability coefficient. This is the permeameter closed, and this is open. The filter is opened and the water is sucked inside by the vacuum in the vial. And over there is a data logger and pressostat which measures the variations of pressure versus time, giving a permeability coefficient. I skip this animation. Conclusions. In CPT practice, some problems occur when there are no standard conditions. For example, when reaction angle in the penetrometer is poor, not penetrable layers, friction, CPT test has to be carried out from a floating barge or platform. These problems can be overcome by using CPTWD, but only accepting a noticeable increase of difficulty with the execution of the test. Actually, CPTWD is quite tricky and difficult to be used. In order to improve the use of CPT rigs and CPTWD equipment offshore, we designed a reactive system which allows heat compensation and could be applicable with some adaptation to standard rigs. In addition, almost any method of drilling and sampling could, in theory, be arranged with the wireline. But this development could bring to the integrated all-purpose system where any tool for testing sampling coring can be considered as a plug-in in order to get the widest range of data with the best cost-effective ratio. The development of such integrated system, eventually with the possibility to work with a heat compensation, would be a breakthrough, especially in nearshore and offshore geotechnical deep survey. Thank you. Muito obrigado.
Thank you, Mr. Sacchetto. We are slightly behind schedule, so we will proceed with the last presentation. Sorry. That's measuring energy in dynamic plumbing.